This webinar, Turning Challenges into Advantages, what current practices teach us about future battery design and sustainability. This event is part of the extended project in collaboration with the EU-INGENIoUS Cluster. This cluster is a key European Union initiative driving the development of next generation battery systems. The cluster, just a second. Okay, so the cluster entails several different projects funded under the same call. We have, of course, Extended, Tempest, VersaPrint, NextBat, and BAT-S. So today, for the webinar, we will take a closer look at how current practice across these projects are not only helping to overcome key challenges, but also revealing new opportunities in the battery sustainability and innovation. We will begin with a brief introduction and context setting, followed by an overview of the 2023 EU battery regulation, highlighting some of the key requirements and what they mean for researchers, industry, and policy alike. Then we'll shift into a more informal, let's say a coffee table discussion with 7 experts across our cluster, and they will be sharing their insights, lessons learned, and ideas for how we can translate today's challenges into tomorrow's advantage. We encourage all of your participation. You can communicate with us via the Q&A, but we will also have some polls for you to answer. And of course, we welcome your questions and comments. So let's begin. Let's dive into this. So regarding our experts, we are happy to have as a keynote speaker, Rafaela Gonçalves. Rafaela is a product and process development engineer at INEGI. She holds a degree in environmental engineering from the University of Coimbra and focus on the sustainability assessment and regulatory compliance of battery technologies. So in this discussion, we will also have, and I will not refer to all of their bios, you can find them in the link of the webinar, but in this panel of discussion, we also have Morshad, which is a mechanical design and software engineer at AB, representing the extended project. We have Jeremy Warren, a senior project builder at Applus Rescol. We have Marco Bianchini, Senior Sustainability Technologist at Lomertov. We have Saurav Patak, Project Manager, Battery Regulation, working at BMZ. And we also have Emmanuel Lorenzo, Project Manager from INEGI, helping us take some conclusion of this webinar. And during the webinar, we will have as a moderator, Fernando Machado, General Director of Portugal Battery Cluster. So, Rafaela, the floor is yours.
Hello, everyone. Just one moment, please. Okay. So, as Catarina said, this webinar is an initiative of the EU-INGENIoUS Cluster, and it's being carried out by the extended project. And to briefly introduce the extended project, this project is a strategic European initiative assembled to revolutionize semi-solid state battery technologies. The extended brings together a dynamic team of academic institutions and industry leaders from across the entire battery value chain, ensuring a comprehensive focus on innovation, safety, sustainability, and circularity. The project involves 19 partners from 10 different countries and will run over a period of 36 months. Okay. And today I'd like to talk about the European Union battery regulation and its impact on the industry, the challenges it brings to the battery value chain, and some innovative responses that we are already seeing in battery design. and lifecycle management. This European Union regulation entered into force in August 2023. The purpose is to regulate the entire life cycle of batteries, from design and production to end of life, and also the collection, reuse, and recycling. This regulation covers all battery types placed on the European Union market: portable batteries, industrial batteries, electric vehicle batteries, starting light and ignition batteries too. The key goals are to ensure sustainability and circularity across the battery life cycle, promote responsible sourcing, and reduce environmental and social impacts, and also improve transparency through digital passports, and also mandatory reportings related to recycled content and carbon footprint. Okay. As you can see on this timeline, several key obligations from the European Union battery regulation are being phased in gradually over the next decade. And let me walk you through the most important milestones. By December this year, 2025, we will need to meet minimum recycling efficiency targets, which define the minimum percentage of battery mass that must be recovered. And at least 65% of lithium-based batteries should be recycled. And there are other percentages for nickel-cadmium batteries, which is 80%, and 75% for lead-acid batteries. Also, started in February, carbon footprint declarations became mandatory, and this declaration must cover the entire battery life cycle of the batteries, and this is already a mandatory thing to do. Well, moving into 2026, batteries will start being classified into performance classes based on their carbon footprint. And this is a key step towards setting clear maximum thresholds, which are expected to become mandatory from February 2028. And from this point onward, only batteries below these carbon footprint limits can be placed on the European Union market. But going through 2027, the focus shifts to transparency and traceability with the introduction of the battery passport. This is a digital record that will contain detailed and standardized information about each battery. It will include the materials used, manufacturing data, carbon footprint, and so on, performance, safety indicators. And also by this year, 2027, the manufacturers must meet minimal recovery levels for key materials, 50% for lithium and 90% for nickel, cobalt, and copper. Then in 2028, the manufacturers will be required to declare the share of recycled content in their batteries for lithium, nickel, cobalt, and lead. This coincides with the enforcement of carbon footprint limits that I talked before, meaning that only compliant batteries may be sold in the European Union market. Looking further ahead, by 2030, lithium-based batteries must reach 70% recycling efficiency. And by 2031, we must meet more ambitious material recovery targets, 80% for lithium, 90% for copper, nickel, and cobalt. And also start meeting minimum levels of recycled content, 6% of lithium and nickel, 16% for cobalt, and 85% for lead. And finally, by 2036, these minimum recycled content levels will increase even further, 12% for lithium, 15% for nickel, and 26% for cobalt, and also 85% for lead. And these evolving requirements are not just about compliance, they are reshaping the entire battery value chain, and they push for greater transparency, circularity, and sustainability, encouraging manufacturers to rethink how batteries are designed, sourced, and managed through their life cycle. And one of the major challenges we face today is dealing with batteries that are produced more than 10 years ago. These older batteries are not designed to be easily dismantled, reused, or recycled. They can contain mixed chemistries that are sealed with ways that make the disassemble dangerous, for example, and also have no embedded data or traceability. There's also no visibility into sourcing of critical raw materials, and this can create ethical concerns, since some of these materials may have come from regions with poor labor or environmental standards. And these batteries, they will need to meet the requirements of the battery regulation, which include these obligations that I talked before, of recovery and recycle components. And while that poses a technical and logistical challenge, it also offers a valuable opportunity. It shows why we need to design batteries differently from the start, with circularity, traceability, and second life in mind. But understanding these limitations of past battery designs, by understanding this, we gain powerful insights to shape the next generation. And in recent years, there's already been a shift toward batteries that are modular, repairable, and recyclable. Principles such as design for disassembly, reuse, recyclability are gradually finding their place in how the industry approaches modern battery systems. And an example of this shift is the European project Extended, which aims to develop next generation of battery pack systems. And as I talked before, the innovation of this project is to use the semi-solid state battery cells. And the goal is to create modular, lightweight, and eco-design batteries with high energy density, long life, and full circularity. And these are being achieved through these designs for recyclability and for second life. And these specs also are be monitored by an advanced battery managed system developed not only for optimal performance during the first use, but also the potential to support the second life applications. And to wrap up this battery regulation, it's not only a legal requirement, it's a roadmap for a more sustainable, circular, and responsible battery ecosystem. It presents real challenges, especially for legacy systems, but also good opportunities for innovation. And the key challenge we face is twofold. One hand, we need to find safe, scalable ways to bring legacy batteries into compliance with today's regulation requirements. And on the other hand, we need to make sure that we are truly moving toward the more sustainable circular battery systems designed from the start to be recycled, traceable, and ready for second life. Thank you all for listening me, And we can move forward for the next speaker.
Thank you, Rafaela. I think, yes, we can start our discussion. So, Fernando, I'll give you the floor.
Good afternoon, everyone. It's a pleasure to be here to discuss with you battery regulations and why this topic is so important for Portugal, and why this topic is so important for us, Battery Cluster Portugal, which I'm the general manager. Because we know very well that climate change is the biggest challenge facing our world today. Europe is committed, Portugal is committed to achieve a climate neutral society by 2050. But we know very well that only batteries allow us to store energy when it's available and use it when it is needed. Additionally, we have drivers of change as the market dynamics, the advances in storage technologies, the need for an independent value chain, and the scarcity of resources. But we have a good news for us. Portugal is the ninth biggest reserve of lithium in the world and the biggest in Europe. And it's why a couple of entities from the university, RTOs, and private companies decide to create the Battery Cluster Portugal. And Battery Cluster Portugal aims to promote and coordinate initiatives that cover the entire value chain of energy storage and battery technologies in our country. And because of this, this event is so important for us and is a huge is for us a huge pleasure to be here with you and to try to do a good job to moderate this so important panel of specialists, of experts in battery regulations. So, Katarina, I think we are prepared to launch the first pool of questions to the audience.
Yes, just a second. Sorry. Okay, can you see the pool? If not, let us know in the chat, please. If yes, we will appreciate your answers.
Yes.
Thank you so much. We have 10 answers so far, so let's wait a little bit for everyone to respond. And you can see the results, correct, in the chat?
We can see.
Yes, okay, perfect.
And people, what affects the others?
Okay, so we have now 26 responses. 27. Our speakers are also welcome to respond if you want.
Katarina, I don't know if it's the moment to put some questions to our specialists, or should we wait for?
I think it's okay. They have the pool open, so they can keep responding, but we can continue with the questions, yes, to our experts.
So I think now is important to listen Patak Saurabh about this question. So what do you think is the biggest challenge in meeting current battery regulations?
Okay. So yeah, we are basically battery manufacturing company, and we have like 250 products in series, so batteries. And from manufacturer's point of view, like we develop the battery, manufacture it and sell it. So regarding that, and I'm responsible for the compliance and battery regulation here. I feel yes, there are many challenges. Main thing is battery regulation is not yet clear. Yeah, for the many articles, delegated act is not yet come from EU Commission. And so, for example, carbon footprint declaration, product carbon footprint, that delegated act was supposed to come in February. It is not yet here. Customers are continuously asking for it. Like, do we have product carbon footprint? Then we have to show them with the references that, okay, the delegated act is not here, so carbon footprint is not there. Then also there are some articles like removability, replaceability of e-bike battery. So they want to basically each cell should be removed and replaced. That's pretty hard task. Like the e-bike batteries, for example, which are developed like around 4 years ago, those don't have that kind of possibility. So uh, that kind of thing. Then the performance durability document that we have to send with all the e-bike industrial battery, then electromobility battery. So that document, there is also no clear, uh, it is not clearly written how to calculate it. Like basically it is related to the aging, and they are doing research parallelly, but the delegated act is not there. So, and also for ESS, energy storage system, there is, so for there are some safety tests, and they have just written the test, but the norms are not yet published. So when the harmonized norm will come, then we have to consider it. But I have checked the tests, and Joint Research Center of European Commission, they have published like possible norms, and the tests I have checked, those cost like around like each battery almost 120 to 150,000, including all tests. So the tests basically. So these all will increase also the cost of the battery. So I'm saying it from not from really innovation perspective, but as a manufacturer perspective. So just the budget and cost. And yeah, so and these all documents should go into battery pass. So yeah, I feel the battery pass is the biggest challenge, and behind that those documents and like preparing those documents and uploading it, and it like the preparation of the documents will cost a lot. So I feel those are the main challenges.
Thank you.
So battery pass.
Yes, digital battery passport is a huge challenge for all of us. But now I would like to invite Mohammed to share with us your point of view.
Hello, this is Morshed from Avesta Battery Energy Engineering. We do most of the activities regarding the batteries. I skip this part and go to the main point first to answer some parts from Surab. So as you know here, as a first point that you mentioned regarding the carbon footprint declaration, even as you know, regarding the finance, we have the report of the 2023 now in Europe. So I mean, we always have 1-2 years for these types of declaration more. We never reach even, we are far from the real-time data, not only in the footprint, but in the carbon declaration. So this gap might be helpful in some points, even though it's not clear. I agree from some aspects. The second point that we always consider that there are no numbers on the standards, and just it is my personal understanding. For instance, when from the regulation point of view, we put numbers on such a stuff, we kill the market, and we show some ways to the producer to find some shortcuts, not to have the right option. For instance, years ago, a country put limitations on the washing machine usage of water and electricity. Then okay, the producer just reduced the amount of water, and then the result was have less clean clothes. So these are the points that should be considered when we speak about the standardization. Anyway, homologation is really complicated. And finally, these types of standards sometimes work. For instance, from IMO for ship or marine application, it has worked. And if I want to answer the question from my point of view, recycling requirements appeared will be the biggest challenge. As it is really ambitious, then in comparison with lead acid batteries, it is not developed and it is underdeveloped. Then the other points that some techniques, for instance, pyrometallurgy, can lose all the entire lithium in the process. And sometimes when we speak about the recycle or not, the cost of logistic 38.3 sometimes make it more expensive that even we might to prefer to find a way just to do it somewhere else, not to use it end of life. And finally, the worst one, as you mentioned, it might be the ERP, extended producer responsibility, uh, because a battery manufacturer must finance free collection and recycling programs, which is really a headache. And the competition is not easy in a place like EU where everything is transparent. If you want to put it in another context that you can use shortcuts easier and do the, I don't want to accuse anywhere, but and I'm very careful about this word, when you want to do greenwashing, so it's easier. You say I did it and done, but in a place like EU, everything is controlled very hard. So it might not, it will increase the cost, which lose your competition. But for sure, there should be tax and subsidies will can improve the situation from social economic point of view. And all of these things are personal. I don't want to say they are the most right perspective.
Thank you, Morshed. Now I would like to ask the other speakers if they would like to have any comments for this question. If not, Katrina, I think we can jump to the next question.
Okay, thank you. We launch the second poll. We can talk a little bit. I don't know if it is important or not to say that for the first poll, we have a diversity of answers. Let's see now for this poll. I think we can keep it open, but we can proceed.
Let's continue with Morshid and try to discover how do you think current regulations are influencing battery design?
So the short answer is all of them, but I think I can speak now about your favorite topic, which will be a little battery passport 2. So I think the first, from the material point of view, if we want to consider that, so such a stuff in a free market will lead to the pushing innovation in new materials. So as you see, there are some options on the market. A lot of them are for sure research, and a lot of them for sure will not never reach any place. But if any of them will reach, we won. So for instance, the PFAS free binders, cobalt free, focusing on the new, not new, but the cheapest solution these days, LFP batteries reaching $50, $55 per kilowatt hour, and organic cathodes and silicone rich and such a stuff. This is the things that push the market to reach the new materials, plus the research has published from Microsoft the new batteries that can have less than 70% of lithium in cathode and some parts. This is the first part. But the second point, that these days I think it will be hot topic until 2-3 years, will be the slowing down development due to the compliance challenges. For instance, as the other colleagues mentioned, it is the battery passport is the one of them. So first we have the certification. If we are lucky and we pass the internal testing procedure in the factory, then we will have another testing, then the new thermal propagation runaway test, and then a lot of them, you know, tons of them. And if we are lucky a lot, we lost the most important things, which is time. And this delays the time to market. And when we lose time to market in an industry like battery, we lose a lot of competitive advantage in where we want to compete with the other countries. So here I think one of the things that burden everything, the other one which is the has the highest vote here, I think 13 people, more than half, is that I think it is one of the most attractive one because it leads the circular battery industry by setting new targets for material recovering and recycled contents. And this leads to the other aspects which help to increase the battery longevity, and then the second life usage, and finally new algorithms and new application where we can have the better ways to increase the life cycle of the batteries. But when we speak exactly about recycling, we should consider that how mature is it, and until when we can reach there. We can just focus on recycling and lose the market, or we can be a little, not neglect, but be a little safer or modest and give our producers, especially inside Europe, some intensive, some opportunity, some delay in time, and let them do their best to reach the market. I don't want to say that the same things happen for farming in some countries, and even less after 10 years when something happens, farmers comes out and, oh no, we cannot accept this, we don't want to same thing happens to the batteries. But this is the things that it might be a trade-off. The last point I don't speak, it doesn't have any vote, but the point that we should consider that in the other industries, I think you might, for instance, pharma industry. So even if you use any types of pills and you face a problem, the whole chain can reach why it happened. And even in batteries, we don't have a right QR code. So it looks like complicated. But when we compare it with the other industries, at least for instance, the chemical industries, that Europe is really major. It has a lot to do. Here in Belgium, Umicore, Solvay, at least all the headquarters of all Europe are here. And so it has a lot to do. And unfortunately, here we don't have a lot to play in case that Europe can be a pioneer here, because he has all the know-how from the pharma or chemical industry. So these are the 3 points, and my final vote again is for the first one.
Thank you, Morchid. And now, Marco Bianchini, what is your opinion about the influence of regulation in the battery design?
Yeah, so thank you very much first for having me. So maybe I will share my opinion more from a sustainability expertise point of view. There is not much to add from what Morshad said, especially about the trends we see in how these new regulations affect the design in terms of materials. So we're talking about novel chemistry, even beyond lithium, solid state batteries with higher efficiency and so on. So from that point of view, I think you got it pretty covered. Also from the point of view of recycling is definitely an important point of view, because when we think about the competitive edge, especially here in the European Union, maybe with current chemistry, we might be little bit late, but that is very important to set these targets in order to build a value chain, a battery value chain on the long term. Since we are maybe lacking in terms of volumes of materials and these critical raw materials, especially, right? So that's a definitely important point. And then the maturity, as it was said already, of these recycling technologies, because if we'll have to include a certain recycled content for this critical raw material within batteries, it's definitely important that we are able to not just to recover this material, which is good from an environmental point of view, but also we need to recover battery grade materials, and that's another challenge on this topic. Maybe finally, my last addition will go more on the system level, so not really on materials and chemistries, but more on system level. That is also very important. What we could see and what we discussed within our project, the VersaPrint projects, is also about what incentives would have manufacturers or end users to design system for circularity, in order already to give a second life to these batteries at the end of their very first life. And we think that incentives coming from that type of stakeholder is not great, and that's where we think is having a regulation in place. Is actually very useful. And this is actually a big focus in the VersaPrint projects, since some of these battery components are actually designed in order to enable this easy to dismantle system, or easy to reassembly, to remanufacture, so to give a more circular perspective, let's say.
Thank you. Marco, thank you all. Would any of the experts like to add comments? No? Katarina, I think the floor is yours.
Okay, so we launched the third pool. Also, you can have any comments into the chat if you'd like. Okay, so we have 15 answers so far. Let's wait a little bit more so everyone can answer. But we can keep the conversation going. So, Fernando, if you want,
Yes,
you can.
I will. Yeah, okay. Thank you, Katrina. I will maintain in Marco, and because Marco is a specialist in this topic, I think it will be very important for us to hear from you. What is your answer to this question?
Yes, thank you, Fernando. I think it's so I'll refer again to what we're working on in the VersaPrint project, and since we have different OEMs in this project, and we kept on this discussion on what are the main needs and requirements, and what would they prioritize in terms of features of these batteries, no? And so I think that's important to keep into account together, and it often goes hand in hand with the regulatory and compliance aspects, right? And interesting, what came out from these discussions were that well, first of all, there is not only one answer. I think it really depends on the use case that we are talking about. But generally speaking, cost is always one of the main drivers, right? And we're talking about initial, like the capex, initial battery cost, not really the cost over the entire life cycle, like the total cost of ownership. And that relates a lot in terms of European competitiveness. It relates a lot with the regulations in place, such as the carbon board adjustment mechanism and so on, in order to keep the industry competitive against, I don't know, for example, Chinese batteries, right? And if that is true, especially in the automotive use case, carbon footprint instead, it's always been maybe a little less important. And I'm just referring to this one indicator, but it's let's say the whole environmental impact, right? It is important, especially because it relates to costs as well, right? But now we can start seeing some trends, in the sense that if before in the automotive use case you would have cost and reliability as the main parameters to take into account, now it's more like cost, carbon footprint, and then reliability in this order. So there is already a shift in this trend, and it's most likely due to these new regulations coming in. Then, of course, there is other parameters to take into account. Lightweighting is a huge trend in the automotive sector, so the energy density of the overall battery system is definitely important. And then one last interesting thing about especially the automotive use case is that lifetime, so extending as much as possible the lifetime of these batteries, maybe is not so is not in the first place, in the sense that lifetime should just be enough from an OEM point of view, right? So they would probably not go the extra mile. So that's also where regulatory requirements are very important, no? In order to maximize from a sustainability perspective. It is then very different in other use cases. If we think of like stationary energy storage, or one of the use cases in VersaPrint is the aerospace or aeronautics use sector. In this case, I mean, safety is always important, but in this case is where safety is like the key aspect to take into account. Simply because if you don't comply with certain safety standards, you'll never have that battery in that application. So that's where it is definitely an important parameter. Cost is always important in terms of competition, and that is pretty straightforward, I think. And then from an environmental point of view, from an engineering point of view, weight and volume are other aspects to take into account. That's a very engineering response, right? You have some certain space allocation, a certain weight, maximum weight that you can add to your system, and that you have to respect. So in conclusion, I don't have only one response, but definitely cost effectiveness and safety standards are, in my opinion, the most important requirements here.
Thank you, Marco. Now let me ask Jeremy if you have the same opinion than Marco.
Well, from my side, I would say they all go hand in hand. Obviously, at the end of the day, if we talk about things from an industrial application standpoint, cost is what's ultimately going to determine whether or not a particular battery design gets, adopted. But on the other hand, in order to make anything practical, it has to comply with obviously safety standards, the environmental impact, and it needs to be efficient. Because if it only lasts 100 cycles, it is not going to be something that is attractive for the consumer either. And I would say I would speak especially to safety standards, because that is something also that I think these days has a significant impact for the consumer, at least in terms of what they see. Because obviously, you don't see, for example, a lot of news coverage of internal combustion engine car fires, but you can see a lot of battery electric vehicle fires on the news because it's spectacular, it's it's new, and it gets hits.
It's sexy.
And that has a very negative impact on battery electric vehicles. It makes people more hesitant. And you can say that the chance of a BEV fire is what? I think it's like 30 times less than that of an ICE. But there's part of, you can design batteries, you can do all of this, but at the end of the day, everything also has to trickle down to the consumer. Everything, and I think part of this is, okay, we have, as technology designers, as OEMs, as technology implementers, we have responsibility to comply with these certain regulatory requirements, and they're put in place for a good reason. But I think also we need to, I think we need to do a better job of also transmitting why they exist. Why, for example, there are standards for batteries, and why, most importantly, Europe is pushing for better safety standards in batteries and newer technologies. And then the same thing, why, the average person, they buy a battery electric vehicle. I'm not even sure how many really understand that these are lithium batteries, or what the difference between a lithium and a sodium battery is, or what the difference between a lithium ion, a solid state, or just an LFP battery is. And this is an important part of everything. And I think everything ties together. It's for us, when we design and we bring new batteries to the market, to design higher capacity, higher efficiency, that are safer. And most importantly, have that lower environmental impact. But we can't just do it and then have a battery that will increase the cost, for example, of a vehicle by 200%, because that won't work either. Because at the end of the day, vehicle OEMs, for example, they're fighting a very intense battle with outside manufacturers that can undercut us on cost. And so all of these have to tie together. How do I put this? We can look at these regulatory requirements also as a strategic advantage, because by using them intelligently, they also give us a market advantage to say we have the most advanced batteries, we have the safest batteries, we have the most efficient batteries, and most importantly, the most environmentally responsible batteries. So I think it's a matter both of communication and intelligently exploiting the regulations to our advantage. Not exploiting is not the best word, I guess. Intelligently designing our technologies to be part and to work with the requirements.
Thank you, Jeremy. Katerina, I think we can jump to the next question.
Yes, we just have the next question on the chat. Thank you all for these insightful comments. Thank you, Jeremy. Okay, so the next question is, which new battery technologies do you think will have the most significant impact on regulatory compliance in the next 5 years? Okay, I think we can continue. The audience is responding.
Okay, so let's continue with Jeremy Warren, and try to figure out your opinion about this question.
Okay. I would say that at least the way I look at it, it's a question of short term versus long term. In the short term, recycling technologies and solid state batteries are going to be the most important things. Simply because we are essentially locked into a lithium economy for the time being. Over the long term, however, technologies such as sodium chemistries, multivalent chemistries that are abundant, these will, well, from a sodium chemistry, for example, obviously that will give us more access to non-critical raw materials as the source for the batteries. And that's really important for Europe, because at least at that point, we will be less subject to constraints from outside of Europe for our supply of lithium. And then if we look even further afield, when we start talking about multivalent chemistries, that will ultimately be a solution for achieving higher energy densities over the long term. But these are things that are much, much further in the future. Even though we are starting to see early versions of sodium batteries, in terms of what I would see as widespread uptake, it's probably going to take a while. And so in the interim, we already have millions of vehicles on the road that use lithium. And I would say over the next 5 to 10 years, we're probably going to still see lithium vehicles of one way or another, whether it's lithium ion or solid state. And so in order to maintain both our strategic independence and a viable economy on this, we have to be able to advance towards more modern chemistry, such as solid state, that are safer, and have good cycle times, but we also need to complement that with good recycling approaches. Because if we don't do both, we are going to have serious problems.
Thank you. Would any of the experts like to have a comment?
Totally agree.
Okay,
we do
so
have a question
Katrina.
in the chat. Antonio is asking, how about flow batteries? Maybe he is asking.
Excellent point. Yeah. And I agree also that redox flow batteries or hybrid flow batteries are also, I would class them in the alternative chemistries. And they have, I will be honest, they are quite fascinating. And they do have good advantages. It depends on which particular chemistry you're talking about, whether it's vanadium or whether it's some of the other more advanced, like bromide or something like that. And compared to a battery, whether it's lithium ion or a solid state, I guess they have their advantages in certain configurations, not, for example, for mobility, But I would use the example of the setup. I know there's a setup at Fraunhofer in Germany that's hooked up to their wind turbines that stores energy. And they use it then when, to buffer, to pull energy off when there's no wind. And flow batteries, I would say, are an excellent solution for that kind of thing. And they are very complementary. So, yeah.
Thank you, Jeremy.
Okay. Yeah, I think we don't have any more questions in the chat. So, Katrina, could you
Yes.
jump to the next question?
Okay, so the next question I'm going to launch the poll right now is what technological advancements do you think will be crucial in meeting regulatory requirements in battery design?
And about this topic, I will invite Morchid to share with us your opinion about the crucial technological advancements you think it will be needed for regulatory requirements. Morchid, I don't know. Yeah,
I'm
okay.
waiting more responses. Okay, not to
Okay.
effect, not to bias. Okay, so I will go one by one. So regarding the recycling, as everybody has spoken, and now hot topic, just some examples, like the hydrometallurgical processes. Some of them claim that they can achieve 95% of the recovery of the metal, but again, consider that none of them are mature. And last year, one of the hottest topic, 10 topics MIT published was the recycling of the lithium ions in parallel with this hot topic of AI and such stuff. So it means in reality, it's really crucial and important, as everybody has spoken. There are the new other techniques that they are claimed that, for instance, a direct recycling that can have the 80 to 100 percentage of the original performance with less energy consumption, which are done by AI driven systems. And this wave of the AI, not the LLMs, I mean the prediction and image processing AIs, which are very crucial, and I think they will work soon, and at least they increase the efficiency and reduce the time. Just a very simple example, I think this is the time. For instance, you have several machines and you want to have a person for your recycling system. In less than 1 day, he can interact with the machines, where he can change different formulas, and if he goes any system wrong, it doesn't need to have tons of sensors. You can have limitations, and with a very simple system reduce the cost and increase the time to market even for recycling. But again, the second point, the AI and data driven systems, digital passport, we have spoken, the IoT, and I have just mentioned the example which has an overlap. And finally, hopefully will again be a hot topic, which will be the blockchain. As you remember, it was, and now it decreased, and again I think it will go again and will be hot topic again and again. And this third question, I think a third part, which is solid state batteries, I think Jeremy has covered it very well. Thank you, Jeremy. I don't need to speak about it anymore. And the other points, that the sustainable and sourcing technological of raw materials can be very helpful. For instance, the technology called direct lithium extraction, DLE, and they significantly reduce water usage because, as you know, in the mining, we sacrifice a lot of water to have the lithium, and sometimes we use the oil for the not we, I mean, in general, people use fossil fuels for the recycling of lithium ions. So it's very weird why it happens. So we should be aware about the whole chain, that what happens. I mean, we should start from the first point, that is it clean or not, and what is the whole life cycle assessment of the system.
Thank you. Thank you, Morshid. Patak, Sarab, do you have a different point of view about this topic?
Yeah, I think yeah, that's true. So the recycling technologies will be the important topic basically, because I was just checking in the battery regulation. So till the December, we have the recycling percentage should be 75% for lead acid batteries, and lithium based batteries 65%. And basically this kind of question exactly came from the customer some days back. Okay, do we found the recycler who will actually uh, provide the documents regarding it? So like what I'm saying, like the document that okay, they are already achieving it and all. So that's why I was talking to the many recyclers now, or recycling systems which will contact recyclers now. So yes, I feel that's the currently big challenge, because that we have like just now, how many, just 6 months to search it as a manufacturer.
Thank you. Any question from the audience? If not, Katarina?
We have nothing so far
The
from
floor is
them,
yours.
so I will launch the pool. We just have 2 more pools, and then we can do our closing remarks. So in meantime, if you have questions, you can use the time now to have it into the chat. Okay, so this pool is about how do you see regulatory pressure affecting the sourcing of materials used in the battery production?
And for this question, I would like to invite Jeremy Warren to share with us your answer, your vision for this topic.
Yeah, this is this is a very interesting question, because this goes both ways. In general, I will say, and I'll be clear, that I think it's a good thing to be stricter and to push regulations on what we do and how we do it. Case in point is the lithium mining in the Atacama Desert, because the overexploiting there has it's already a desert, and it's used up an excessive amount of water of what is there in the lithium mining. And so what needs to be done, by essentially pushing towards the improvement of the chemistries, the improvement of the sourcing, and basically more responsible approaches to it. That means that we advance. And that's the whole point of this, that we work together to advance in the technologies of batteries. If we always do the same thing, if we essentially participate in a race to the bottom, we will lose. And that's the reality of it, because when faced with competition from outside Europe, we cannot compete on overall quantity or cheapest cost. And so we have to focus on technological innovation, sustainable and ethical sourcing, and regulations are a necessary evil to achieve that. They have to exist. And amongst other things, they also help to put us all on the same footing, to guide us in the same direction. Now, sometimes nothing is perfect, nothing is perfect, and regulations evolve over time. But in general, they are, in my mind, it is a good way to encourage us to move together in the right direction.
Thank you. Morshid, could we relate this regulatory pressure with digital battery passport?
Yes. From my point of view, regarding the way that we have to force it to the digital battery passport is from different points. First, as Jeremy mentioned, the water issues and a lot of other things that we should consider in LCA. The way that the battery passport will hopefully help us will be the traceability of the system. I believe in the free market, and sometimes we might confuse that regulations kill the free market. But from my point of view, in a civilized society like Europe, the things that has the least amount of crime might be one of them, the right way that the rules are generalized to control and have preventive action during the time. So it means that if we have the right behavior in terms of controlling everything, these types of monitoring system will decrease the incentives to the companies who cannot or the people who prefer to use less and easier ways to have higher profits. Finally, the companies try to maximize their profit, and the government should support people. And these types of rules, like traceability, when we can know what comes from where, if it comes from a country that the child labor is very high, or they put people to convey the cobalt with hand without any regulation. So what types of sustainability is it? So in 50 years later, we will ask ourselves that, were we on the right side of the history, or we just sacrificed something to look like more profits for another companies, now accuse the oil that this is not the best option and now just do it in another way. I think this way is the first way. And the second way, here, the best way to protect the EU economy is the circular economy. If we know that comes what from where, we can save it. We are sure that, okay, why should I make jobs for another countries? I can keep the core technology in EU, and if it is needed, I can decentralize. I don't need to put 100% of Porsche in another country, and 3 years later they copy it with 1/10 of the price. and then I say, oh, I am sorry, I lost the market because of the regulation. No, the regulation, right? For instance, it never happened for some car companies, and nobody is able to copy them because they keep the core in Europe. Some others just put it there, and unfortunately, you see the results now.
Thank you, Morshid. It was a great point of view. And now, Katerina, I think we can jump to the last question.
Yes, so the last poll is, in your opinion, which part of the battery life cycle will see the most significant regulatory changes in the next 5 to 10 years? We have a question. I can read it. That says, from FEMA, that says, I would like to know the expert's opinion on how artificial intelligence can help with the GDPR.
Can I answer it?
Sure.
Right, battery passport might infect the GDPR, and companies do not like to share the information of their end user with the others. But there are some techniques in AI, like for instance, as we have spoken, like for instance, the federated learning and the other techniques that we can have the behavior of the data, not the direct data, or the other topics that have been done in the other markets, like the blockchain, and where the other currencies sometimes are not possible to trace to respect the GDPR. So it is totally understandable the concern that it might affect people, but as I spoke and I told before, and people mentioned here, these types of things like the battery hasn't happened before, but in Europe the other things very similar with different contexts happen. So it is just needed to transfer technology from the other points to here. Then we can respect all of these GDPR and the related privacy sector.
Thank you, Morshid. Katrina, I think we can discuss this question with our experts. So the last question is about life cycle assessment, and I will ask Jeremy Warren about which part of the battery life cycle will see the most significant regulatory changes in the next 10 years. So what is your opinion, Jeremy, about this?
I would say both the first and the fourth are going to be the most important over the next few years. And granted, okay, we're talking about the next 5 to 10 years, and at that point, over the scope of starting about 5 to 10 years, we're going to probably see a more major uptake of newer chemistries, whether it be sodium or other types. That is probably going to have a very important effect on manufacturing and sourcing of materials. That will probably, maybe not immediately, but it will have a rather important change on the overall value chain for batteries, at least in terms of the raw materials. But at the same time, we have to look at the lithium that's already in circulation and the the question there is that we are going to be rapidly reaching a point where we're finally, we've got there's a lot of new vehicles on the road. There's a lot of middle of life vehicles on the road. And in 5 to 10 years, we're going to achieve the point where we have a lot of end of life battery packs on the road. Right now, our big problem in the recycling value chain is that there aren't enough end of life lithium batteries and we also don't have a big enough capacity to really generate enough lithium, because it's estimated, I think by 2030, we'll need around 400,000 tons of lithium. But the plants for recycling will only have a capacity by then of about 70,000. So there's this disparity. And even if we do get plants up and running to recycle everything, there's going to be that we're going to have a big effort to organize all of that, because we're going to reach a point where we're going to have a lot of packs suddenly become available, and we're going to have a lot of lithium to deal with. And whether that be, okay, we have cells that we can reuse and, for example, put them in stationary storage or put them in, bikes or something like that. We can do that. But if these are truly end of life cells, then we need to re-inject them into a value chain one way or the other, and that means recycling. And that means we either have to, if we cannot meet the demand, the 330 kilotons that are left, how do we get that? Do we get that through mines in Portugal? Do we increase our recycling capacity? How do we handle that? And that's why I say for me, it's both of them. The other ones build into this, but at the end of the day, we are going to, over the very long term, probably see some major changes in the manufacturing and sourcing. But at the same time, as we deal with what's coming through what's in the market and what's being injected into the market in terms of lithium, we're going to have to deal with that as well.
Okay, I think, and now, before close the panel, I will invite all of the experts to do their own final comment and to answer to the final question we have from the audience. And the question is from Laurent Gauthier. And he said, please, do you know if last recycling battery regulations are also impacted all the soft foam polymers used in battery packs, such as elastic pads, sealings, silicone, interlayers for thermal barriers, etc. that are actually just burned when dismantled? Do the experts here know what is the expected trend about these kind of materials? So I think this could be our last question, and I think the question could be for all of you.
Can I start?
Yes, please.
Because this will give me a good chance to talk about Tempest. Because actually this is a big issue for us. Now this actually brings up another issue, which is also related to recycling. We've touched on it briefly, but it's another thing that needs to be considered, and I'll come back to it in a minute. The main problem we have right now, when you talk about the foams, the sealings, and all of that, is that yes, these are materials that are bound very tightly or embedded very tightly, and they become very problematic when you're looking at the disassembly phase. And so having a method to cleanly disassemble the components in a pack is absolutely critical. And I will just say, hey, that's what we're doing in Tempest. That's one of the things we're doing, is we are looking at methods to essentially bond things together in the cell, but also at the end of life, give the ability to very cleanly and easily disassemble them. So we are looking at that. But at the same time, the other thing I want to bring up, because there was a mention of burning. When we talk about pyrometallurgy and hydrometallurgy, which are the two primary methods for recycling materials out of cells, we very often talk about energy usage and yields out of them. But the other thing we need to consider at the end of the day is also the waste that comes out of those. Because essentially pyrometallurgy, when you boil it down to what it really is, you're burning the cell. And so you are generating a lot of fumes from that. You can have smoke scrubbers and that kind of stuff. But there's still that. And the same thing with hydrometallurgy, you end up with a lot of acid waste from the treatment, from the dissolving and, from dissolving the cell in acid. So that's the other thing. And again, we'll go back to Tempest. We're also working on a technology for that as well. And so I will say that there are efforts underway to address this. And in terms about talking about trends, yes, I will say from at least my perspective, we are, research is thinking about it. There are efforts underway funded by the European Commission to overcome some of these issues.
Thank you, Jeremy. Any other expert?
Just in cell phone, as Jeremy mentioned, the similar concept has been started to release, and there are some efforts, but not finally has done. But there are some efforts for the headsets, for cell phones, and sooner or later it will happen in the EVs and the home application. But as Jeremy mentioned before, until 10, 12 years, whatever we do it now will be on the land at least for 12, 10 years later. So we should have planned for them too.
Thank you.
Maybe just one last comment from my side. I wrote it in the chat, but I think that's if it's true for batteries, that's very related to a lot of products now. And I would especially refer to this ESPR. So it's the regulation for the eco-design of product sustainable products, basically, sorry. So it's not just about the recycling, but it's really about the way that we design products in a way that we can facilitate separation of components, especially when they include critical raw materials. But so that's maybe more the case of batteries, but really in general. So basically to maximize recovery, to get easy access to components and so on. So there is like a lot of steps before getting to recycling, So according to all these circular strategies, the 9 Rs and so on. So without entering too much in detail, I think that's really important for a lot of products now. Before, this regulation was more dedicated to electronic products, and now it's really extending to a lot of different type of products. So yeah.
Thank you, Marco. Patak, Saurabh, do you want to do a final comment?
Basically, regarding the materials and polymers, I'm not a perfect person.
Okay.
It's okay, Fernando. I think.
Thank you. Yes, from my side, it was very grateful to be here with you, to hear you, to learn with you. So thank you. And I think this is the feeling from all of us. Thank you, Catarina.
Thank you. I think Emmanuel will do a brief wrap up, a few conclusions about this webinar while we launch a last poll about your feeling about this webinar. So go ahead, Emmanuel, the floor is yours.
Okay, first of all, thank you, everyone. Thank you to all the speakers and the moderators. nice to see you. It was a very engaging conversation. And thank you to all the participants. So we started this journey of looking into the battery regulation that's in force, that's defying the way that we rethink design. And this is the part of the turning the challenges into advantages. We spoke about this throughout your comments, some smart strategies that you guys use and how you see these problems was very refreshing. We can see here, for instance, BMZ launched a comment regarding that one of the challenges is that the regulation is not clear. Delegated acts are still to be defined. So I agree with this one, and this is something that we have here, and we move maybe slowly in Europe regarding regulation. But we also saw the other side of having this regulation, where regulation avoids this boomerang effect. Machado was giving the example of the washing machine, the water, and then we wash it twice. So we have this boomerang effect in sustainability, if we want to. So this also helps us deviate from that, and this was quite an interesting finding, a key take that I had, and also the way that we will have this new materials that will help us be more competitive, lower cost, and more critical raw materials free. So this is also one of the key takeaways, that if you follow the regulation, we will also tend to go to less critical raw materials. Marco brought up here at the end this nice topic of the eco-design, which is highly tied with the battery regulation, especially when it comes to passport, because the Sustainable Product Development Regulation and the Sustainable Product Regulation has the digital product passport defined there. So this is the way it ties to this. So this is, I believe that the batteries will be a leading field in this topic. So it's also, I am also happy to be part of this leading adventure. So this is nice, and this is also discussed here. Regarding sustainability, Mark also mentioned this, go beyond lithium, higher energy density, all of this in pro or towards sustainable battery development. Jeremy done some comments here in terms of prioritizing priorities of design. Which would there be? You spoke here of there's an industrial point of view that looks into the costs, and this is not a very sustained manner. We cannot only look at that dimension, or else we'll be lacking in terms of the other dimensions, the safety. You gave the example of this news that we see. I agree with you. This is a quite an interesting way for us to picture what's going on and why is the safety so important. So this is also our get back as Europeans. What we have this regulation, and we are on the side of the safety and putting the people ahead of all this. I think it was Machado, he mentioned we should be on the right side of the history, and that's correct. So when you look at these dimensions and do the sourcing and do this responsible sourcing and look into the recycling, we are avoiding that we have children in Africa mining with their hands. So this is also our way to push forward and make ourselves competitive, and not just playing a price game, but playing a smart game with the other stakeholders in this value chain. There was a topic here that I liked a lot with this. I think it was Moshe mentioned this, AI as an enabler for competitive recycling. This is quite an interesting one. I believe this also will help make recycling a easier step, despite we have lots of challenges, and this is the key point here that brings me to the end. I'll wrap up now. When we're speaking about the design, this is more towards the end. We're speaking about the design of the battery packs. Mark mentioned it, Jeremy as well, and I know what's going on in extended. So all these projects are working on the design for us to have better possibility to recover the material, to reuse the material, and all of this. So this is also our driver and our motivation towards this regulation. And the regulation here is not I do not see it as a bad cop. I see it as a catalyst for our competitiveness, for us doing smarter decisions, for imposing us to think out of the box and to think with a in a manner that perpetuates what we are doing and not just a short-term or a quick decision, but also as a way to make us more resilient as companies and us as people that are involved in this project also to think out of the box. So that's a challenging part that I like a lot. So this is my key takeaway. So hopefully I was fair and just with your comments and I captured the essence of all of them. If not, please override me and say so. But yeah, it was a pleasure to be part of this and help push forward with this webinar. Thank you to all. And thank you to Katerina for also helping us organize this. Yeah.
Thank you. Thank you all the speakers. Thank you, Rafaela, for the keynote speak. And thank you the audience for sharing their ideas with us via the polls and for the comments that you did in the chat. I hope to see you soon in our next webinar of the EU-INGENIoUS Cluster. Please follow the cluster and wait for more news regarding this series of webinars that are starting, that started here and will go further in time. So thank you all. Have a nice day.